Hi guys, welcome to grade 11 Analytical Geometry. I just thought I should spend some time recapping the concepts we have established from grade 10, okay? The first thing that we established is that if you have got 2 points A with coordinate X at A, Y, and Y at A, and of course point B with a coordinate XB, and coordinate YB, then you can find the distance, okay, using this formula here. AB squared is actually the square of the differences in the coordinates. We derived this formula. If you want to know where it comes from, you're welcome to check out the grade 10 videos. And of course, another way, if you want to make things a lot easier for yourself, is to take the square root and express this formula as I am writing now. Right. So you all know this at this point, right? Good. Then we spoke about another concept of equidistant points. Okay. So if I've got 2 points or 3 points maybe, if I've got this, all right, and I've got P, and I've got A, and I've got B, and there's a marking that this line is equal to that line, then I know that actually P is equidistant from point A and from point B. In other words, AP is equal to PB or BP, whichever way you want to say it. Another important concept that we established rather in grade 10 is that if I've got a line, and this is point A and that's point B, and I've got a midpoint M, right? So in other words, this line AM is equal to line MB, and the coordinates of the midpoint is then XA plus XB over 2 and YA plus YB over 2. That's what we've got. Okay, so I hope you can see that actually then XM is equal to that thing, and YM is also equal to that thing. And of course, if you want more depth, you are really welcome to watch the grade 10 videos on analytical geometry. They're already up on the channel, okay? Now, we also spoke about the gradient, and this is very simple. Gradient of AB is change in Y over change in X, okay? And you can just say, well, Y at A minus Y at B. What is important here, and I need to caution you even in grade 11, if you start with Y at A in the numerator, you have to start with Y at A in the denominator. I mean X at A in the denominator. Don't make the mistake of switching the coordinates or the order of the coordinates. Please avoid that. Then, of course, we spoke about parallel lines. I know if I've got 2 lines that are parallel, now how do we know that lines will be parallel if it is given? You know you are going to have actually some arrows that indicate that the lines are parallel. Then let's call this line AB, and let's call this line CD. Then we know that the gradient of line AB is actually equal to the gradient of line CD. We then spoke about perpendicular lines, okay? In other words, lines that have got an angle of 90 degrees between them. And these ones, we said, again, if this is AB and this is CD, we know that the product of the gradient, that is the gradient of AB times the gradient of CD, should be -1. Finally, we spoke about collinear points. Points are collinear, guys, if they are on the same line. So if I've got A and I've got B and I've got C here, then we say A, B, and C are collinear, and therefore their gradients should be the same. It makes sense because they are on the same line. Okay, you understand that? AC, and this is BC. Okay, so whenever they give you these terms, you need to remember that the implications are the ones as I'm indicating right now. Then you closed off the discussion of analytical geometry by discussing the equation of a straight line. Okay, the linear equation. You know that y is mx plus c, or some of you have learned from my school of thought, y is ax plus q, or f of x equals to ax plus q. Actually, this is usually when we use functional notation, we will do that, of which I hope you are now familiar with because you have surely done functions. And we know that in a case of a vertical line, if you've got a vertical line, right, then you have an equation that says y is a constant, x is a constant, usually k. So vertical line, if you can think about it, if I were to draw the Cartesian plane here, okay, then if you've got a line here and they ask you for the equation of this line, it doesn't seem like a line, clearly. So let's take a different color. If they ask you for equation of this line, then you know the equation will be in the form x equals to k being this coordinate there, okay? And in the case of y, of course, and you've got a straight line again, and in this case, this one does not seem to be straight there, then obviously again here, you have got y is equal to k being that coordinate there. All right, that is another important element that we established. This is basically the summary of grade 10. Quickly, let me talk about the gradients. I hope you know, or if you're not, but you are already aware of the slope man. If you've got a gradient of a line going up there, it is positive. Gradient of a line going down is negative. And gradient that is parallel to the x-axis is 0. And the gradient that is perpendicular or parallel to the y-axis is undefined. And this is the slope man. I'll probably send a picture in the group chat. Fellows, that's about it. In the next video, we are now going to discuss things around the grade 11 level, and it is not really anything bad or harmful. It's just more interesting stuff. So I'll check you guys later.